Good morning and welcome. Can I just get a microphone check from Trish or Jess? Thanks. Just chuck it in the general chat. Wonderful, thank you. Hi, good morning. So thank you for joining us here for the TIPE 2022 industry track. And it's my pleasure to be the host for us in the APAC region today. I'm just going to share my screen as well. All right, so what we're here for today is the industry track. So just giving you all a shout out, if you're not quite in the right track, if you're here for the technology, people or economics track this morning, feel free to just click out, head back to the main stage and find the speakers that you are keen to see. Obviously, we don't want you missing out on anyone that you have specifically logged in for and are joining to see today. So welcome to the APAC industry track. My name is Karen Reynolds and it is my pleasure to be the host for you through these next couple of sessions today. I would like to begin by respectfully acknowledging the traditional custodians of the land from where I join this gathering today. It's the Bunurong Boon Wurrung and the Wurundjeri Woi Wurrung peoples of the Eastern Kulin Nation, and I pay my respects to their elders past, present and emerging. I extend that respect to our Aboriginal and Torres Strait Islander peoples joining us for this conference globally. So I've been a member of the Women in 3D Printing Oceania community for about 2 years now, and there may be some familiar faces on this virtual conference today. Welcome back, and for those of you I've not met before, a warm welcome. Very glad to have you with us here today. So typically on a Wednesday, you'll find me working for Lockheed Martin Australia in a division of the company called Stellar Lab, where I'm the Integrated Systems and Additive Manufacturing Lead. So I have the pleasure of running a project called Agile Shield, which is an integrated architecture project which is used to intelligently defeat improvised threats. And on top of that, I get to do some work with our organisation from the US in relation to additive manufacturing. So myself, I've got about 10 years of industry experience. I'm a chartered professional engineer in both systems and mechanical engineering. And I have recently completed my master's with a focus on additive manufacturing, which was inspired by my time in the defence sector. So working on the NOLCA program and also the landing helicopter stock ships in the engineering governance roles. I obviously was inspired and saw the need for real-time on-demand manufacturing that our defence community could rely on. And so that's why I got interested in 3D printing in the first place. So that's a little bit about me, and now I'd love to bring up our digital ambassador, Trish. So I'm just going to share screens with Trish. Just 1 second. Here we go. So I'm just going to introduce Trish. Welcome up to the stage, Trish. Feel free to turn on your mic and camera. Hello. So
good morning,
Trish. Brilliant. So Trish is a marketing specialist with AML 3D. Some of you, I know AML 3D have presented at quite a number of conferences prior, so some of you may be familiar with their industry work here in Australia. Their home base is in South Australia, and that is where Trish is joining us from today. So as the marketing specialist at AML 3D, Trish is responsible for overseeing the company's marketing and communication activities, and today she's in charge of overseeing all of the technical stuff in the background as we do the presentation today. 2021 was a big year for Trish and her company, successfully claiming 2 world firsts in metal 3D printing, the world's largest shipboard fitting and the world's largest oil and gas high pressure part, both successfully verified by DNV and Lloyd's Register respectively. The organisation is pioneering and leading metal additive manufacturing globally with new technologies which drive the mission and the goals of AML 3D, and they believe that 2022 will be an even bigger and better year for their organisation. And so now I'd love to pass over to Trish, who will just run us through, for those of you who are unfamiliar with the Remo platform, how we're going to run the chat and the Q&A today in this presentation mode. So Trish, over to you.
Thanks, Karen. Thanks for the intro, and good morning, everybody, and welcome to the TIPE Conference Industry Track for APAC. I'd love to take you through how to chat with each other while we're in this presenter mode, and to ask questions for the Q&A portion for each speaker. So if you look at the right of your screen, you'll see 3 tabs. If it's closed, just press the arrow and it'll open back up. you'll see the tabs Chat, Participants, and Q&A. So if you are wanting to do general chit chat and have conversations between each other that can be publicly reviewed, please use the chat function. If you would like to private message a presenter or fellow attendee, please use the Participants tab. This message will only be seen by the person that you are communicating to. And if you have any questions, please ask them under the Q&A tab. With this Q&A tab, we've got the option to upvote questions. So what we will do, we will select the highest upvoted questions to ask the presenter towards the end of their speaking role. So back to you, Karen.
Lovely. And I have brought up the wonderful Jessica Thompson onto stage, and she's going to start sharing her presentation. So Jessica Thompson is a design engineer with Rheinmetall Defence Australia. Her session today, so she's going to be speaking to us on driving printer mitosis. Now, Jess is an Australian design engineer with a passion for advanced manufacturing. After graduating her Bachelor in Medical Engineering, she initially worked in research across orthopedics, biomechanics, robotics, and neuroscience at the Queensland University of Technology, or QUT as we like to call it here. It was about this time that she bought her first 3D printer, and it was a kit from Kickstarter. And after some time in research, she moved into education. As part of that, she was involved in helping with classes and running their own various design and technology workshops. She's helped with a makerspace as well as electronics and robotics spaces. So helping teach design and technology classes to students was rewarding for her and further developed her passion for industrial design and advanced manufacturing methods. As shared, now she's progressed over to the defence industry, and her current role has allowed her to develop her skills with Rheinmetall Defence Australia to provide additive manufacturing knowledge for those who need it. And with that, welcome, Jess, over to you.
Hi, everyone. Just a little bit of a heads up. I've only got the one screen, so I can't really see what's happening in the chat or anything, but I'll change back over towards the end so that any questions can be asked. So with that, I'll start. I've got my talk on driving printer mitosis, which I thought was a great pun at the time, but I feel like I should perhaps explain it a little bit. So this talk's going to be on how you can multiply your 3D printers and your printing capabilities. So how do you go about building a proper business case, and how do you start implementing those things to be able to increase those printing capabilities? I'd like to respectfully acknowledge the Quandamooka traditional owners of the land from where I'm presenting, and their elders both past and present. Got a couple of pictures I've taken of local wildlife that I thought I might share for any of our international participants. Okay, so let's get into it. So step one is defining the problem. And this is all about defining what you actually need to get out of this. How do you choose a printer when you don't really have a end goal in mind? So this is everything from what are you actually going to be printing? Is it prototyping parts? Is it parts to test fits together? Is it parts to check what your final product's going to look like? How does it fit into your process? Materials, finishes, sizes. So there's no point looking at resin printers when realistically what you need is going to be a metal printer. And like the same goes for the volumes we're printing. So some of the printers you'll come across are going to be great for doing super high volumes. Like there's the belt printers and things that are coming through where you can do the same print in a production line and just keep it going indefinitely and get a whole bunch of nice prints. But that's not particularly useful if you're doing completely new unique pieces every time. In that case, maybe you're better off looking at printers where you're actually going to be able to get super high levels of details every time the first time. And it's also worthwhile having a look at what level of post-processing you're going to need as well, because with your 3D printing, it's not necessarily going to be a finished product straight out of the vat or off the bed. And there may be extra bits of processing you need to consider. So is it going to require extra staffing? Is it going to require anything extra that you need to put in as part of your budgeting constraints? So step 2, how do you go about identifying the correct people? So there's both sides of this. The user side is pretty easy. Who's already using the printers now? Who could potentially use the printers? So across departments, within your own department, are there other people who could benefit from the use of a printer? From the business perspective, who's actually going to be signing off on it? So you've got management staff at your level who are probably going to be interested in tasking you with coming up with a business proposal. But you also may be interacting with people. So we have an engineering tooling person who's in charge of signing off on decisions and putting forward what potential solutions there might be. And for my current employer and my past employer, it usually has to get ticked off by a whole bunch of people in the process. So you want to make it as clear as possible who you need to sell this to as part of your business case. So step 3, this is where you actually start doing the work. It's tempting to think of this as mild subterfuge, but this is where you actually start talking to those people. So it's all well and good to have an idea and put forward an idea, but you really need to have other people on board with that idea first. So that's when you start having the conversations in the lunchroom. You're like, oh, hey, I'm into 3D printing, or we already have a 3D printer, and oh man, it looks like we need some more for XYZ reason. One of the things that I can't stress enough is building your user base. So this is a little bit dependent on how you'll be using your printer, whether you'll be sending prints to someone to print on an industrial machine, or whether you're using a desktop printer or two, just each person is sending their prints directly to the printer. I've found recently that what was holding us back a little bit was the fact we had only a handful of users of the printer, but there were actually a lot more people interested. So I spent the end of last year, in that last little week of before Christmas, where everyone's sort of trailing off on their work, and I had to print some test cubes to check that everything was all calibrated on our printer. So using that opportunity to train people up, and I've almost tripled how many people can actually use our printer. And that's an important number for when you're trying to put forward your business case. The other important numbers are to actually start tracking how much you're using your printer, what materials you're using, and anything that comes up in the way that technically is going to cost the company money. If your machine's down for 2 weeks, that's going to start costing the company money, because then prints either get held up and delays happen, or it has to be get sent off site, and that might cost, it's generally going to cost a lot more to get printed. So those numbers are what is really going to help sell this to as like a proper business case. So what are you already printing in terms of volumes, how often, and have some specific examples in mind if you already have them. So that can be anything from something that's happening occasionally to one-off prints that have saved the day. What is the cost of printing currently? So what is your material costing? How long is it taking? What would be the alternative to this? So that might be, well, if I 3D print this 3 times here, it's going to be done a lot quicker. I can have all the exact tolerances I need, have the proper finished product before sending it off-site for a much more expensive print or manufacturing process like CNC, if it's something like metal. And you're effectively saving the company money by doing some of those test prints on site. Also have what you plan on printing. So this is something that's come up across a few different places for me, where it's all well and good and be like, oh, well, we can print things that would help this thing, but do you have a specific model? So on a vehicle, it could be a specific kind of mount that would save weight. It would be doable on site. Maybe there's a holdup in the international manufacturing of that item. From a school perspective, because I've come from an education background, it could be something as simple as these are the projects we do each term or each semester. Here's something from the workshop, but this is how we can pair it with, say, history. So history might have a specific topic coming up where you can print artifacts and have those ready to go. But having specific things in mind is super important and goes a long way in justifying the potential purchase. This is also a really good time to get an idea of what your budget is. So there's no point going and looking at multi-million-dollar machines when your boss isn't going to sign off anything more than $2,000. There's a range of printers, and you can get something suitable in any of those ranges. Realistically, there's ways to go about different things. So this is where your business case starts coming together. Build a decision matrix, and I'm happy to talk about this more a bit later as to how to go setting that up, or if you want to email me later, that's fine as well. But this is where you start attributing values to different things. So for materials, it could be a case of, well, I want a printer that's not locked to specific brand materials. It could be specific, I need to be able to print nylon with this machine so that we can put it on vehicles. Because potentially, particularly in Australia with how hot it is, printing something in PLA to stick on a vehicle that's going to be housed in a very hot shed is going to look really droopy and sad after a little bit of time. So for me, looking at materials in particular was super important with any future purchases we make. Print quality is another big one. It depends on what you're printing. So there's no point looking at an FDM style machine when you're printing super small, super detailed models. When you're looking at that, it starts making a bit more sense to perhaps look at resin. Connectivity is another big one. So working in defense, you don't necessarily want it to be a networked printer, so having the option of having local ways as well. Whereas if you're working in an office where that's not such a big deal, really having network connectivity could be a huge deciding factor. How do you set your prints to run? How do you get them sent to the printer? How do you organize it? The print environment's another one that I am particularly passionate about. If you're printing in plastics or powders or anything, you need to consider the people who are working around the machine. If it's in a well-ventilated area, that might be okay for that type of printer, but you need to consider whether it needs to be an enclosed printer, whether you need specific dust extraction, PPE equipment, print size. So I'm working with Lynx vehicles, so they're quite a large tank style vehicle. There would be no point in me getting a teeny tiny little FDM printer, because it would be 10 centimeters by 10 centimeters by 10 centimeters, and things we're wanting to print are quite often more than 50 centimeters in at least one direction. So it would make sense for me to put a higher weight on print size than, say, print quality, because I'd be happy to do super thick layer lines and get a faster print, a larger print, than getting a super detailed print. Setup time. So this doesn't necessarily end up being a huge issue with desktop printing, but it's definitely something to consider if you're going for a more industrial machine. Some of the peak printers can take up to 2 hours to turn on. Is that something you actually have time for? Do you need someone to be able to have time to babysit the machine while it's heating up and set things to go? Just things like that. So step 5, part 2, actually look at the printers. So there's a few ways to go about this. Obviously, there's some really big names in printing, so they're always a good place to start. I'd also super recommend looking at your local and your national suppliers. If you're looking at desktop printers, if it's a super low cost setup and you're looking at like the Creality style machines, that's fine. And buying them online is super easy to do. If you're looking at spending even at that $2,000 starting point, when you're looking at like Zortrax printers and the entry-level Ultimakers, those printers, usually their suppliers will be your greatest help. As you start working up in the levels of and price ranges, your suppliers are your biggest important factor. They can really make or break how your printing experience goes. So definitely check with people local to you, because they'll be able to provide on-site support. They'll be able to provide phone-based support. They'll be able to provide some tips and tricks depending on who it is. And it's really something I just super passionate about, because it's really hard being stuck with a printer that doesn't work and you don't have any support. It also means they'll be able to provide training. They'll be able to help your whole printing journey and help you scale up if there is another step involved in the future. So this is where you start to actually do the write-up. So you've got your decision matrix, start filling it out with those printers you've come across. You may go into it all gung-ho like I did, thinking I need an industrial printer, I need it to be able to have like the best quality prints every time. Turns out when you actually break it down into a matrix, not the case. So go ahead, go for it. Go through all of those processes with that decision matrix, justify your solution. So you need to put forward how it actually is going to benefit your company. And then you need to present your solution. Really keep in mind who your stakeholders are. You may need a tech write-up, or you may actually need a nice short presentation for like the general managers and the people actually signing off on it who don't understand what's necessarily happening behind the scenes. And then get your printers. Get them installed, get training, upskill yourself and as many people as you can, and start your documentation processes. You really need this to fall back on for when you're not there or things start going awry. And then keep it going. So really make sure you've got some user categories set up. I've got super users, basic users, standard users, and that sort of depends on what level of work they can do with the machine. And I definitely recommend having upkeep schedules for your maintenance, your repairs, and keep track of your metrics as you go. This will help you in the future when you keep going through and have to do it all over again. I was going to do a bit of a talk on where I went wrong, but it looks like we've only got about 5 minutes left. So I will skip over to questions, and I'll come back to
Awesome. Thanks, Jess.
Screen.
Can you hear me okay, Jess?
Yes.
Brilliant. Thank you so much for sharing your talk. I'm actually in the market for my own personal 3D printer, and I think you raised some really brilliant points that I need to consider before I make my purchase. So thank you for that. Now, we've got a couple of questions that have been upvoted in the chat. So from your experience, how do you handle naysayers to this kind of approach? So obviously there'll be some skeptical people in industry.
Oh, definitely. There's always going to be someone naysaying, and that's when your numbers really are super important. That's why having metrics of what you're doing and where it's actually going to save money is super important. If you've got those numbers, you've got justification as to how it's going to help and how it's going to work, and it starts becoming a bit more irrefutable that it's not just going to be a little gimmick that sits in the back of the corner of the office.
Thank you for that. And we also have, how would you recommend a business identifies these potential opportunities to do 3D printing?
Yeah, so talk to the people who are already making stuff in your business. Sometimes it's very easy to get lost in the what ifs and the possibilities, but if you've got engineers in your company who are already designing objects to be made, talk to them about what their process is. It's not necessarily the end step. You might not be worthwhile actually going, we want to print something to be a final product. It might be a test piece for you. So that's part of how we use it in our processes. And even in my education experience, what we were doing, we were using it as a step as part of our process. So maybe you're 3D printing a mold to make a resin cast, things like that. Think outside the box.
And I'm just going to pull that thread a little further. So you've worked across a variety of industries, which is, an experience that some of us haven't had. So have you noticed the difference between each of the three, between, research, education, your biomedical, and now into the defence sector? Can you shed some light on that?
Yeah, so a lot of the main difference really comes to money and time scales, which I'm sure a lot of people would be already aware of in their own industries. But in industry and research in particular, having like a very specific plan on what you want to do, and whether it's a final product first, whether it's part of your process is super important. Whereas in education, it's a great learning tool. And being able to give students an opportunity to sort of test and play with things without having super expensive manufacturing costs, super difficult manufacturing costs. It's really a great tool in that scheme of things. And realistically, that's how we should be approaching an industry to an extent as well. So being able to test some of those wild, wacky ideas like, oh, I wonder if this random thing would work. That's a really great way to test it with a low cost way, potentially, depending on machines, obviously. Printing it in a metal machine is going to cost infinitely more than it's going to cost to just use an FDM desktop printer.
Brilliant. Thank you, Jess, for sharing your insights today. And thank you from everyone who is attending the APAC Industry Track. So thanks, Jess. All right.
Thank you, everyone, for listening.